Okay, now for question 8 of the MCQ, alright, the following diagram shows a valve in the section of a vein. Okay, which of the following statement is correct? Now, recall that in veins, right, okay, the blood pressure is low. That means that the blood is flowing slowly. Now, in that case, it is important, okay, that we have valves. Okay, those are valves, okay, where my cursor is, and it prevents the backflow of blood. So, blood will only flow in one particular direction. Okay, so from this diagram, right, blood will flow from Y to X, okay, in this particular direction. Okay, now, what is the correct option here? Okay, now this valve, right, okay, will be forced open when the blood pressure in Y is greater than X. Okay, and this will ensure that blood will flow from Y to X in only one direction. Okay, now suppose that blood is at X, right? Okay, you can see structurally the valves here, okay, actually discourages the flow of the blood from X to Y. Okay, so all in all, the overall direction of the flow of blood in this case would be from Y to X. Okay, from Y to X in this direction. Okay. Okay, moving on. Okay, so the answer here is D. Okay, now next question. What is the correct route for blood flow in the human? Okay, so this one here relates to the different structures of the heart. Okay, and then of course there are organs here, okay, lungs. Okay, so we have the left atrium, we have the ventricle, and the atrium. Okay, so okay, we will go through this flow of blood in the heart, okay, in greater detail in the next few lessons. Okay, but let's take a look here. Okay, maybe we can take a look here. Okay, now as usual, okay, this side here is the right side of the heart. This is the left side. Okay, now in a heart, okay, let's talk about one side, just the right hand side. Okay, there is the upper chamber and there is the lower chamber. Okay, this is the right atrium, this is the left atrium. Okay, this is the right atrium, this is the right ventricle. Okay, whereas this is the left atrium, this is the left ventricle. Okay, so blood will flow from the rest of the body, right? Okay, to the right atrium. Okay, and then the right atrium will contract, and then the blood will flow to the right ventricle. The right ventricle will then contract, okay, and then it will flow out of the heart, okay, through the pulmonary artery to the lungs. In the lungs, okay, there is exchange of gases, and then the oxygenated blood will flow to the heart, okay, through the pulmonary vein. Okay, so this pulmonary vein here will bring the oxygenated blood to the left atrium, this chamber here. The left atrium will contract, will bring blood to the left ventricle. And then the left ventricle will contract and then bring blood out of the heart through the aorta here, okay, and to the rest of the body. Okay, so again, we will learn more about this, okay, in the subsequent chapter. Okay, but the answer for this would be, okay, from the right atrium to the right ventricle, and then out of the heart to the lungs. There is exchange of gases in the lungs, okay, and then the blood is returned to the heart, okay, inside the left atrium, and down the left ventricle, okay, the lower chamber of the heart. Okay, the answer is D. Okay, let's take a look at question 10 of the MCQ here. Okay, which blood vessel here has the highest pressure? Okay, now always recall, okay, the blood with the highest pressure is always the artery. It's always the artery. Okay, so which one here is the artery technically? Okay, so if you take a look here, okay, this is the heart. Right side of the heart, the left side of the heart. Okay, blood is returned to the right side of the heart here. Okay, and these blood vessels A and C are thus, they are actually veins, okay, because they return blood to the heart. Okay, and veins technically have a low blood pressure, so this cannot be it. Okay, now let's consider B and D. Okay, B and D, okay, B, right, if you take a look here, B, okay, it brings blood, okay, from the lungs to the heart. Okay, so this is again a form of a vein, right? Okay, so this is low blood pressure. Okay, now let's take a look at D here, this blood vessel. Okay, this blood vessel brings blood from the heart to the rest of the body. Now, this is a form of artery. Okay, and as you can see here, from the heart to the rest of the body, right? Okay, it covers a long distance. So the blood, right, must be really of high pressure so that the blood can travel further. Okay, the answer here, okay, the blood vessel with the greatest pressure is actually D. Okay, and where is the force coming from? It's coming from the heart. Okay, the heart, the left side of the heart must really contract strongly. Okay, and with enough force so that the blood is ejected, okay, and be carried at longer distances. Okay, so let's move to the structured question, question 1 to 3. Now, over here, we have, okay, a person, okay, who is training at altitude, okay, for several days, okay, 0 all the way to 14 days. And then they measure, okay, the number of red blood cell count, okay, the average number of red blood cell count, okay, across the days. Okay, as you can see here, there is a trend, okay, over time, the mean number of red blood cell increases. So there are more red blood cells, okay, in the blood. Okay, and this is a natural adaptation of the body. Okay, now question A. Okay, they want you to plot his mean red blood cell count and draw a line of best fit. Okay. Okay, so over here, right, this would be the x-axis. Okay, this column here is the x-axis. And this column here is the y-axis. Okay, the mean red blood cell count. Okay, so a line of best fit would look something like this. Okay, let me explain to you the important parts here. Okay, so we have covered this multiple times. Make sure that you plan, okay, your axis here, okay, the scale here, such that when you draw the graph, right, it covers at least 3/4 of the space given. Okay, so this line here, okay, that I've plotted, okay, it covers at least 3/4 of the space given. Okay, so this is a plus. Okay, and try to maximize the scale. Okay, so we are given a lot of space here, try to max it out, stretch it out. Okay, so the maximum value for the x-axis, right, is actually 14. Okay, so make sure you try to stretch it out. Okay, from 0 to 14 here. Okay, not 0 to maybe 15 here. 15, this one is too short. Okay, so we stretch until 15 here. Okay, similarly for the y-axis. Okay, and then also important, the plots. Okay, make sure you plot it correctly. Okay, if your plots are inaccurate, you will not get the 1 mark. Okay, and lastly, okay, when you draw the line of best fit, okay, try to go through as many plots as you can. Okay, and at the same time, okay, it's a best fit. It's a nice curve in this manner. Okay, make sure that you don't have any extrapolations. Okay, extrapolations means extension of the line beyond the last plot, extension of the line before the first plot. Okay, there is no extensions there. Okay, so you can pause the video at this point, okay, so that you can do some rectifications on your graph. Okay, then otherwise I will move on. Okay, now the question is asking, use the graph. Okay, use your graph to calculate the increase in mean red blood cell count between day 2 and day 8. Okay, so it is essential that you use your own graph here. Okay, so just gonna draw a simple line. Okay, day 2 is around here. Okay, so day 2, if you interpolate here, will be about 5. Okay, interpolate here at the point where it touches the graph, it is around 5. Okay, so for day 2 is around 5 red blood cell count. And then for day 8, okay, day 8 again, okay, the accuracy really matters here. Day 8, 6, 7, 8. Okay, day 8 is around here. Okay, and then you extend the line until it touches the graph. Once it touches the graph, okay, you can just interpolate it. Okay, look at the y-axis. Okay, it's around here. Okay, so it's around, how much is that? Okay, 6.5. Okay, from my eyes here, 6 to 6.5. Okay, okay, but maybe this person maybe do it wrongly. Okay, so it's around there lah. Okay, so it depends on your graph. Okay, for my eyes, okay, so 6.5 minus 5, okay, 1.5. Okay, so your graph may be drawn differently. Okay, so we base it on your graph. Okay. Okay, now next question. At high altitude, oxygen concentration is low. Okay, suggest what effect this will have on the athlete's health when he first arrives on day zero. Now, at day zero, right? Okay, day zero, the body hasn't had enough time to adapt yet. Okay, and the mean red blood cell count is normal. Okay, it's like normal baseline levels. Okay, and at high altitude, high up in the mountains, for example, the amount of oxygen is lesser. So the body at day zero, at least, okay, will struggle. Okay, will struggle. Okay, so he may experience dizziness, breathlessness, feel tired easily. Okay, because there's not enough red blood cell. Okay, that is absorbed into the bloodstream. Okay, and then from the graph, explain the benefit of training at a height of 2000 meters. Okay, so as you can see here, there is a trend. Okay, across the number of days from 0 to 14 days, okay, the number of red blood cell increases. Okay, so you can explain. Okay, explain means why. Okay, with the increase in the red blood cell count, how is it beneficial to the person? Okay, so you can use this explanation. Okay, this increases his mean red blood cell count from 4.2 to 7.1. Okay, hence oxygen can be transported at a faster rate. Okay, this is a key phrase here, faster rate. Okay, to ensure that he can release sufficient energy for exercise. Okay, because ultimately you need oxygen for aerobic respiration. Okay, now question 2. Explain the advantage of each of the following. Okay, so over here we have red blood cell having no nuclei. Now this is a structure. Okay, remember we talked about structure and function. Okay, what is the relevant function of this particular adaptation of a structure? Okay, it is we can store more hemoglobin to transport more oxygen. What about this structure here? Veins having valves. Okay, so as we know already, veins have low blood pressure, so it is essential that we have valves inside, okay, to prevent the backflow of blood. Okay, and lastly, capillary walls are only one cell thick. Okay, how is this enabling it to optimize its function? To provide a shorter diffusion distance for faster diffusion of substances. Okay, this is a key phrase, shorter diffusion distance. Okay, and faster diffusion. Okay, we are down to the last question. Okay, question 3. Okay, over here we have different blood vessels. Okay, so aorta, if you don't know, okay, is the artery, okay, of the heart that brings blood to the rest of the body. Okay, that's the aorta. This is the artery. Okay, I believe this is a general arteries found in the human body. Okay, but both of these, okay, it carries blood from the heart. Okay, so we expect it to have high blood pressure. Okay, the blood is traveling at a high force. And then subsequently from arteries, okay, the blood is carried to the arteriole. Okay, so in terms of diameter, right, the arterioles are a little bit smaller compared to the arteries. And then finally, it is moved to the capillary. Capillaries are even smaller. Okay, so capillaries are blood vessels that surrounds tissues. Okay, so it is where there is exchange of substances between the blood and the tissues. As you can see here, the diameter of the capillary is even smaller. And then we have venule. Okay, so from the capillary, okay, we have the venule. It is still small. Okay, it is still small. And then subsequently, it merges to form a vein. Okay, veins are bigger. Okay, so veins, okay, will return blood back to the heart. Okay. Okay, so my apologies. Okay, so this one is referring to the mean blood pressure. Okay, and then the question is asking here, okay, the table shows the mean blood pressure decrease from 13 kilopascal in the aorta to 6 kilopascal in the arteriole. Explain why blood pressure must decrease in the arteriole before entering the capillary. Okay, now, in the capillary, right, there is exchange of substances. Okay, so it is essential, okay, that blood flow in the capillary is lower. Okay, it is essential for blood flow in the capillary to be slow. Okay, so arteriole comes before capillary. So arteriole branches into capillaries. Okay, and with the branching here, okay, with many branches of the capillaries, you are increasing the total cross-sectional area. Okay, if you add up all the diameters of the capillaries, okay, the total cross-sectional area increases. Okay, so because of this, the blood pressure in capillaries is lowered. Okay, and when this happens, okay, the flow of blood is slowed. Okay, that means the pressure in the blood is very slow. And this will allow sufficient time. Okay, when blood is flowing very slowly in the capillaries, okay, there will be sufficient time for exchange of substances. Okay, so take some time. You can even pause this video to do your connections every now and then. Okay, now we have this question here, figure 4.1. Okay, now this may look a little bit strange, okay, but it is actually, okay, a part of the blood vessel wall. Okay, so if I were to complete this entire drawing, okay, it will be, okay, we will form one circle here. Okay, this way. Okay, and the middle here, okay, would be the lumen. This is the lumen, okay, where the blood is flowing through the hole. Okay, so let's take a look at the blood vessel wall here. Okay, you would automatically notice that it is thick. Okay, it is thick and muscular. Okay, so they want you to explain how the structure of the artery here, which is thick and muscular, is related to its function. Again, it's about structure and function. Okay, arteries carry blood at the highest pressure. So it is important that the artery walls are thick, okay, and muscular, okay, to withstand the high pressure of blood that is ejected from the heart. Okay, so this is 2 marks. Okay, so that's about it. Okay, you can pause this video, okay, to write down the connections. Make sure you have done all the connections, and most importantly, you understand first. Okay, then you do your connections.